Hey guys, good morning all. My name is Amit Sharma and this is the second video in the series of understanding data warehousing. In the first video we discussed about the fundamentals about data warehouse. In the second video we are going to talk about the ETL process. Why do we need ETL? What's the business meaning of it? And we'll try to understand all the aspects of ETL in a very simplified manner. So in order to support my explanation, I'm going to use a couple of simplified examples which we use in our day-to-day life. So let's start with, the class agenda will talk about the very basics fundamental of extract, transform and loading process in order to build the enterprise data warehouse, and then we discuss about what are the tasks associated with the ETL, and then we talk about what is data extraction methodology. That's the first part of the video. In second part of the video and subsequent sessions, we'll discuss about ETL in greater details. Right. So let's start with very basic example. First, we try to understand why do we use ETL? What's the need of using ETL? Right. So in order to understand, in order to make it, in order to explain this, I'm going to use very basic examples which we use in our day-to-day life. So let's talk about the complete life cycle. I have an application over here, a sample example with me. Now look at this, the first Excel sheet. The Excel sheet is simulating an application, a traditional sales processing application. So a sales processing application, I assume this is being used by my front-end executive in Walmart. So every time you go there and buy something, they store all the required information into the application. So the information associated with the customer pertaining to particular sale is in which geographical location, which country, which province the store is located, store manager name, store type, and other information related to the products, information related to the sales, and finally the data related to the customers. So they have some application maybe designed in Java or .NET. They enter the information in the sales information into the application, and when they save the data, it finally goes into your RDBMS, which is your structured data. So your traditional application works in the same fashion. You specify some values into your application and finally it goes to your underlying data source, database. So in first sheet, my all data goes to RDBMS. I also got another sheet which functionally does the same thing what my sheet second does, first does. The difference over here in sheet 1 and sheet 2 is that in sheet 1 my data stores in RDBMS, whereas in sheet 2 the data stores in flat file. A flat file is like your text file, right? Why we are using flat file? There may be multiple reasons behind this. A simple reason could be cost. The company do not have adequate resources and therefore they agree to store the data in flat file. Or maybe they do not have technology, they may not have resources, people. So because of some reason, company decided to store the data into the flat file. So when people enter the value and save it, it goes to the flat file. So a flat file data may look like this at the end of the day. So you see data stores into my flat file. I am using Excel sheet to simulate a flat file structure, which has each transaction has a transaction ID, in which country, which city the transaction happened, what is the address, information about the product and about the customer and all. So all the information we give in the application eventually stores into my database. Right? That's what I want to show you. Now, so I've got two sources over here. One department of my organization uses RDBMS. Another department uses data source as a flat file. Another department, or you may call it sister concern or my strategy partner. So I've got two sources of data, right? That's my requirement. Now, on this data, at the end of the day, my business user like to create a reports. You know, the end result of all the activities which we do is to prepare the BI report, business intelligence report. On top of that, your user can take up business decisions. So eventually, the one thing which you want to achieve is to create sales analysis reports. A simple example of sales analysis could be, you like to see the customer information along with the sales they have made it, right? A typical example of reporting example, all four quarters and quarter 1, 2, 3, 4 and the respective top 5 customers for all 4 quarters. So that's what the first report talks about. The next report talks about, we have a couple of requirements similarly on this. The requirements data has been driven from RDBMS or maybe from my source file, flat file. You see, in the second requirement, I would like to see the average customer sales, and then in turn we have got the sales based on each promotion category. So there are certain reporting requirements are to be built on top of my data source, which you just designed, isn't it? So at the end of the day, I would like to present the report to my business. That's what the requirement is. Now, so in order to bridge the gap between data you receive from the application to the reporting components, at the end of the day, we need to create an ETL operation. So now we have a complete picture. We can understand why we need ETL and how does it add value to my complete process. So ETL means extraction, transformation of data, and finally loading of data. It's a process or a method where you use some means to extract data from your source, one or multiple sources. In my example, there are 2 sources. I'm using RDBMS and a flat file. You use multiple sources to extract the data and finally store into your target system. You may have some target system where your data is going to land up, right? So this process consists of 3 tasks: extract, transform, and load. As you see, the first activity called extracting the data is taking the data from the source system. My source system could be an application like SAP, ERP, or other operational application. This could be a right example for source system. So this is my source system. In my example, the source system is a sales processing application. So data comes from the operational source, and it could be different sources at one time. So in my example, the sources are, the one data source is RDBMS and another data source is flat file, right? Different sources is converted into one consolidated data warehouse, which will help us to perform reporting purpose. So we extract data from different sources, consolidate into common place so that reporting can be built. Now imagine if you don't consolidate them, how do you present it to the user? This is my reporting requirement, right? So let's see this reporting. You're showing the revenue for product category 1, monthly revenue for product category. So you have got months and you have got revenue for product category. Now you see in order to build this reporting, the requirement over here is that I have got data source 1. Data source 1 is RDBMS and another data source is flat file or a structured, semi-structured data is a flat file, right? This is the underlying data source. However, we are not going to show the same thing to one business user. It's not logically correct. Now imagine, sorry, you don't show this report like product category 1, where you say the data source is RDBMS, whereas product category 2 data source comes from flat files. It is not logically correct, right? So maybe if you present the information like this to the business user, product category 1 taken from RDBMS and product category again 1 taken from flat file. I mean, this is not logically correct. You same product category, same report you are showing in a two version, one for RDBMS, one for flat file. This is not logically correct because the business doesn't bother about it. Your data stores where and all the complexity associated with the technology. Business doesn't bother about this. They want one simplified report where they could see, revenue product wise, product category wise revenue. This is they would like to know, regardless where your data stores, right? So in order to achieve this, the first activity is to consolidate your data, club data stored in different sources. So in order to create reporting data source, I need to club my data from flat file plus RDBMS. I need to club this data. So in order to do this, I need to extract data from flat file and then I extract data from RDBMS. Extraction is the first process. The next process is transformation. Now, why do we need to transform? There could be multiple reasons behind this. I'll show you some example for transformation. The one example, we need to transform the data into the format that makes meaningful to the business for reporting purpose. So there could be many reasons where we require transformation. A simple example of transformation you can see. You may need to clean the data. When you bring the data from the source system, data may not be in the format that can be directly used for reporting purpose. For example, this is your report, this is your application, right? And in application, you are supposed to enter the values. For example, somebody has made, I have a member called title, and title is supposed to enter Mr. or by mistake somebody has entered incorrect value, misspell it, right? So this requires to, and we don't have any data validation. So this requires to clean the data, because the data which I receive from the application cannot directly be used for the reporting purpose. So some reason behind this, you need to clean the data, and the data comes from the application may not be appropriate. So that could be one reason where you require transformation. So the transformation says if your data, your incorrect data is, you enter is, rather than using Mr., you write empty, and the correct value should be Mr., right? So you will clean the data and repopulate this or make it correct it by writing some rules. There will be need of filtering the data as well. The second requirement of transformation would maybe you require to filter the data. So in our example, I have a data element over here called store type. Store type is like active, and I've got two kinds of store: active store or a closed store. Active store is like it is still running, and closed store. So in my reporting requirements, says we would like to create reporting only for store type as active, isn't it? So we would like to have some side of filter. My application have data for store type active plus data add. However, in my reporting we need data only for active. So you may require to filter the data once it is received from the application. There may be need of splitting the data column into multiple columns, or maybe the other way around, splitting or joining. Split the column or join the column. The need of splitting the column may be, if you look at my requirement, there is a data column called country. The country consists of country plus province. We have got country and then we have province. Country or a city. This is a city. So in my application, the country column consists of country per province. So, but in reporting, we need country column separately and we need province column separately. So the data which comes from the application may require to split. So my country column would split by using hyphen. Country hyphen and province name. So example given over here. You have got US and New York. So I would split this into US and New York, and my delimiter or a separator would be a hyphen. So that's one requirement where you require data transformation. You can also use rather than splitting the column, we need of joining the column. So I have got over here customer first name and last name. This is first name and the last name, right? But my reporting use, I need to club first name, middle name and last name, because my reporting requirement, I like to see my reports based on customer first name and last name. I don't have over here. Assume you have got a customer full name where you require to join customer first name and last name, right? So that require you to club the join the data. So data joining requirement could be customer first name plus customer last name. So we have seen a requirement for data joining, data splitting, cleansing, and data filtering. There may also be need for transforming data from rows and column. That's called pivoting. We'll talk about this later. Or there may be some complex business rule associated with your data validation, right? So these are certain cases where you require to transform the data into the format that is required for reporting purpose. Data available from my application cannot directly be used for reporting. We require transformation. So that's a high level view. Data comes from application. It lands up into data source. We would like to create a reporting on top of that. However, reporting cannot be done because data is not up to the mark, or it may not be into the format that can be used directly for reporting. So once you extract, you transform the data. Extraction is the first process, and then you transform it. These are the simple example of transformation. In subsequent videos, we'll talk about transformation in greater details. So we discuss about what is extraction, what is transformation. Once data transform, we load into data warehouse or some data repository on which reporting can be done. So I complete this diagram. Data extracted from multiple sources. I use data sources, extract, transform, and then finally you load into data repository. So the reporting can be done. So whatever I am doing, at the end of the day, we would like to show the reports to my business user, on which my users can do business decisions. That's a extract, transform, and load. Now we talk, look at the complete diagram, the complete layer diagram about ETL. So you see, we can split this into multiple layers. You see the end result is a reporting. The final result is a reporting where your users are going to navigate this. And the source starts with, you have disparate sources, different category of source, maybe your flat file, your RDBMS, your transactional system. So the first layer is, we call layer 1. Data comes from disparate sources. We extract the data, transform the data, and load the data into your data warehouse or maybe some common data, some common place we call data repository on which the reporting can be done. It's a simplified diagram. We have a couple of more things to discuss about called data staging and all. We call it front room and we call back room because what is happening behind the screen is not visible to the user. At the end of the day, the users see only reporting and therefore we call a front room. So you see the complete process flow from your application, data lands to your multiple data sources. From multiple data source, you pull the data, extract the data, and load into the common extract the data. You may or may not require transformation of the data, and then finally you load the data into the data repository. On top of that, a reporting is built. So that's your data source and that's your reporting. In between this, your ETL process work. That's very basic about ETL, and this is a complete diagram which talk about the complete process flow. There are certain terminologies I am not discussed about. I would be talking about them in my subsequent classes like data marts and all. So the kind of extraction, there are two possibility of extractions. You can extract the full data or you can extract incremental data, right? So full data, incremental data extraction is something like, in simple words, if I talk about this, maybe I'm creating, everything derives by the reporting. I'm creating a sales report for year 2012 sales report, right? So year 2012 sales report, it means my sales report, if we talk about in terms of month, I call this monthly sales report for 2012. My report may be in terms, it may contain data for January to, the current month is January to December. When I do say full extraction, so full extraction means data will, from your data source, to extract the complete data. So my data, starting point of my data would be January and end point of my data source would be December, I assume. So data is extracted completely from your source system because the extraction reflects all the data currently available in the source system. There is no need to keep track of changes. It means I assume my source system contains 1 year of data and the starting point of my data is January and the end point is December. So it's my monthly sales report for entire year, right? So the complete extraction. Now incremental extract means incremental extraction. So now we don't want to show the 1 year sales report. We would like to show the month over month sales report. The month over month sales report is something like a pretty simple example of a sales report. Like you have months column over here and you have sales, right? So you say in the month of January, what was my sales? In the month of February, what is my sales? So I got sales growth, and growth percent, or I should use a term called month over month sales. Month over month sales and growth percent. So In the month of January, let's take, in the month of January, my sales was 1000. In the month of February, we need to take a month over here to make it more meaningful. This is January. I just swap the order. This is February, right? So in the month of January, my sales was 1000, and in the month of February, my sales grown to 1200, right? So my month over month sales growth will give me the difference between current month and previous month. So difference is 200, right? Month over month sales, and growth percent you can specify. Growth percent. The growth percent is 20% growth. So in this requirement, I would like to capture only current month. You see, only current month sales. So we would like to load the data incrementally. My next cycle would be January to February. Next would be, February to March. Next would be March to April. So my requirement says I would like to capture only current month and previous month, and I like to see the sales difference, the growth difference between 2 months. Such kind of reporting requirement encourage me to upload the data, extra data on incremental basis. So in the beginning we extract data for January in extraction cycle 1, then we extract for January plus February, then we extract data for February plus March. So I have kind of checkpoint, isn't it? At a specific point in time, only the data that has changed since a well-defined event back in the history. So previously we extract data for January, and then we extract January plus February, then we extract data January, February plus March. So we are extracting data incrementally because my requirement is like this. So that's called incremental extract. You extract. So this example would extract on monthly basis. Every month, at the end of the month, we extract last month data. So that's a two kind of extraction. The extraction can be done on online and offline also. A simple meaning to understand online means when your business operation is going on, at the same time you use your source to extract the data. The data is extracted directly from source system itself. Okay, and the extraction process can connect directly to source system to access the source table themselves. So maybe if I take this requirement further, this is my source system. I can directly apply. I can do data extraction directly on top of this. We can directly extract this for our reporting requirement. Directly extract from a source system. That is possibility 1, right? That's called online access. So on one hand, your application is writing data into your RDBMS or your operational system. On the other hand, at the same time, you are extracting data from your operational system. So it's an online extract. Offline extract means, because you use your operation system for your major business activity. So you do not want to, disturb, or you do not want to give overburden your operational server, operational system by adding additional process of extracting data. So what do? You take a copy of your source system and make a mirror copy of it, or you may extract during offline extraction, maybe offline business hours. The data is not directly extracted from source system, but it is staged explicitly outside the original source system. So what we do, as my this source system is primarily designed in order to record day-to-day transaction, and therefore we do not want it to overburden by adding additional extraction process. So what we do, we do not directly report on top of this. We stage this data. Staging is a new term, we got it now. So for now, you can assume staging is like a temporary storage, staging of data. We extract data from your operational system, store into staging so that you do not disturb or do not hamper your day-to-day business operation, and make a copy of your actual system in a staging table. And all the operation reporting you do over here. On top of staging, we further talk about you extract data from staging. Staging would be used to perform all kind of transformation. So now the data transformation would be happening in staging rather than as opposed to we were doing in my source system. If you do directly in source system, you are actually hampering or interfering the actual business operation, and you do not want to interfere into actual business operation. You want your transactional system should dedicatedly be and continue to working as recording day-to-day transaction. Without hampering your transaction system, you make a copy of it and store in a staging area, and all the transformation you do over here, and finally it lands up into your enterprise warehouse. Finally your data goes to enterprise warehouse where the reporting would be built. This is my and your all reporting would be happening in enterprise warehouse eventually. So I would have a finally presentation component over here called reporting component. So the moral of the story is that your ETL is used to extract data from your transactional system, convert into the format that can be used for reporting purpose, which will be used by your business users for taking business decisions. So that's a complete view. Taking data from your application, storing into your transactional system, then in turn store into staging where you perform all transformation, a basic or a complex transformation. Once transformation done, you load into your enterprise warehouse, and finally you load into reporting layer where your users are going to navigate. So that's a complete life cycle of your ETL process. So the same diagram shown over here in a more elaborative manner. You have layer first talk about various sources, disparate sources, and from various source we store data into common source called data staging, and all the transformation happen over here, and then it goes to your centralized enterprise warehouse, and then in turn we create data marts, and finally reporting happen. For now you can bypass data marts and you create dimensions and the reporting done on top of this. So for simplicity you can remove this and assume the reporting directly built on top of your enterprise warehouse. So that's all about the very basics. That's all about for today. We discussed very basics about ETL. Please keep watching my subsequent videos about advanced ETL, dimension modeling, and various other complex topics of data warehousing and dimension modeling. So thanks for joining the call. My name is Amit Sharma. I've been representing BSP Solution Incorporation. We are into training and consulting. Thank you once again for being a part of this presentation.